one of the things I noticed when I was looking up some of the, especially the marine reptiles from this time, was how weird everything is. Like these are either nothing like things that we've seen, since. They're just these enigmatic experiments of evolution that don't really get very far. Or you'd have things that convergently evolve to look like things that we know of today. So like in Placodontia, even though these aren't related to turtles necessarily, they they still evolved to look turtle-like in certain lineages. So yeah, it's a really weird and wonderful time in Earth's history, the Triassic. But yeah, before we get started, I want to just say that the Triassic, that is the first period of the Mesozoic era. So this is the era that's most famous for dinosaurs. So like if you think of the Mesozoic, you're thinking, Tyrannosaurus, you're thinking Stegosaurus. But in the Triassic, the first stage, dinosaurs, while they were around, they weren't necessarily the predominant animals of the land. And then in the water, which we're going to be talking about on this episode mostly, there was a whole bunch of weird and wonderful things. So this is from around 251.9 million years ago to around 201 million years ago. That constitutes the Triassic based on the most recent chart of the International Commission on Stratigraphy. Yeah, so with that said, let's get started. So Cole, you work a lot on Triassic material, particularly ichthyosaurs. So what allowed these things to radiate in the Triassic?
So, in the Triassic, there's this thing called the Mesozoic Marine Revolution, and you're seeing like this big turnover from more like a more Paleozoic type, ecosystem, a lot of reefs and a lot of sessile organisms like crinoids, corals, brachiopods. And as the Mesozoic gets started and as it progresses, especially at the end of the Triassic and moving into the Jurassic, you have a lot of those communities are kind of not around anymore. It happens more slowly than the word revolution would imply, but you're getting a lot higher concentration of nectonic animals, fish, and the big one for especially for the Triassic and Jurassic are cephalopods. We have whole ecosystems that appear to be based on cephalopods instead of fish. At my locality in Fossil Hill, the Fossil Hill member in Nevada, uh, we've we've found fish are rare. They're there. We find fish fossils. Uh, they're usually pretty relatively large, 1 foot plus, but like swiddlefish are real uncommon. That's going for that goes for fish scales too. We're finding them, so we know they're not being like selected out via taphonomy in the fossilization process. But meanwhile, some of these horizons within the fossil hill member are literally made out of ammonites. Like there are so many crushed up ammonites there, and they're ranging in size from my thumbnail to we found a real big one this year that was big. So I think we're looking at like a huge radiation of cephalopods that allows like a very robust food chain to form around that.
Yeah, that makes sense. And let's talk a little bit about what gave rise to this, which would be the end Permian mass extinction, because this was considered the deadliest of all mass extinctions. Like we were talking about what, well over 90% of all marine life became extinct during this.
Yeah, it definitely played a big role in kind of getting this Mesozoic marine revolution started. Uh, prior to the Mesozoic, prior to the end Permian extinction event, we don't have any like truly large uh, predators in the ocean. I mean, the biggest ones are like helicoprions, just great white shark size, maybe a little bigger. The dunk got shrunk recently, so he's not quite the 30-foot terror that we grew up hearing about. But as you move into the Mesozoic, you have an explosion of marine tetrapods. Really, the first marine tetrapod. I mean, I think mesosaurs, some of them were marine, and there might have been some marine hemiphones too, Permian. But like the true like ecological contribution from uh, tetrapods begins in the Triassic. And that begins with ichthyosaurs, who take to the seas uh, at some point in the Triassic, maybe even earlier. We can talk a bit about that if you guys want. And quickly, very quickly, my locality in Fossil Hill is maximum 6 million years post Perma-Triassic extinction event. And they're attaining whale sizes immediately. We're 60-foot animals, 20, 30 tons, uh, and in a very short amount of time.
Hmm.
And a really recent paper from uh, Kier et al. Was looking at described a kind of a symbospondylid type ichthyosaur from Spitsbergen that was just 2 million years after the extinction event. It was already large, obviously fully pelagic and derived. So we're just 2 million years after we've already got large ichthyosaurs on the scene.
Hmm. And why do you think that they would, is that why you think that they would have radiated before the end Permian?
They probably were radiating like probably the earliest triad. It's not known. It was kind of like ichthyosaur esoterica for a bit, uh, where until this paper from I think Kier et al. 2023 just kind of came out and said we should probably start looking at ichthyosaurs as end Permian survivors and not something that came afterwards because it's only 2 million years after and they're already like derived fully pelagic animals. So
Yeah.
it's stretching credulity that all happened in only 2 million. We're getting something like a symbiosis in only 2 million.
Yeah. And you definitely do see an interesting faunal exchange in niches within the Triassic, compared to the Permian and most of the Paleozoic. The big dogs, I guess, of the marine ecosystems would have been the chondrichthyans. So particularly, you'd have like on the ratfish side, you'd have really big Adestus, you would have Helicoprion, like what you said, and you know the
How big
what?
did Augustus get?
Adestus was probably around great white, if not a little bit bigger, but they're all of these size estimates right now are like up for debate. So I don't want to give like specific size estimates on them. But then you also have like Helicoprion, which is larger than your average great white. But anyways, so you had those which were on the ratfish side of things, and then on the elasmobranch side, you would have really large animals like Cyvodus, which again, those are up for debate for how big they got, but they've been, historically talked about as being like orca or near orca sized animals. Size estimates, it's really hard to be super accurate unless if you have the full body, which is, really hard to come by with Paleozoic stuff and with chondrichthyans in general because they're cartilaginous, so they don't preserve super well or super often. But
So
then
like,
what?
they're more distantly related from modern sharks. So the sizing, there's a lot more unknown factor in scaling a helicoprion and using like
Yeah.
a big shark measurement, like great white
Exactly. Because
size.
if you scale it to a great white, you'll get very different answers than if you scale it to a ratfish, which it's more closely related to. But anyways, so with the end Permian mass extinction, chondrichthyan diversity took a major hit. So what you saw is most of the chondrichthyans that were super successful within the Paleozoic, they wound up either dying out or they wound up being reduced to such an extent that they wound up becoming extinct before the Jurassic comes around. So the sharks and relatives that were left over, you would have the Neoselacians and you'd have primarily the Hybodonts. You would see some coelacanths survive, but again, they don't make it past the or into the Jurassic. They become extinct in the Triassic. Eugenodontiforms, which would include Helicoprion and Adestus, that order also survives the end Permian mass extinction, but they wound up becoming extinct within the Triassic as well. So you had true sharks and their relatives that were alive, but these were very small. These wouldn't be animals that we would just like look at today and be like, "Oh, that's a lamniform or that's a squaliform or whatever." These would be very archaic sharks. We don't even have definitive splits between true sharks and batoids because the earliest known batoid that's like unequivocally a batoid would have been in the early Jurassic, but we do suspect that there would have been batoids in the Triassic. But anyways, we know of their existence mainly through tooth histology. So you would have a true shark has what we call a so-called triple layered enameloid, which I discussed with Gilles Cooney, who studies a lot of the Triassic stuff. These enameloid structures, while it's not truly a triple layered, it's something else. That's the easiest way to, I guess, describe it. Whereas your most of your other chondrichthyans, including Hybodonts, which would be a close relative of the sharks and the rays, they would have usually a single layered enameloid. So when you found teeth in the, say, like the Raedan of England, the Somerset locality, you had teeth that were labeled Hybotis minor, but with tooth histology, wound up coming out that they had three enameloid layers, the triple layered enameloid, which would have placed them under a true shark, a Salacian, rather than it being a Hybodont, even though the teeth look like Hybodonts. But yeah, these were small. Hybodonts were I guess, the most successful and diverse group within the Triassic, but even those didn't reach, I guess, macro predatory sizes. So really, the marine reptiles are what took over the role of sharks in the Triassic.
I had to ask, Ben, do you know if anybody's done that with reticulotus?
I'm not entirely sure if they've done histology on Reticulotus, but it would be complex because when we look at batoids and if we look at Heterodontus, which has lateral crushing teeth, kind of similar to like a Hybodont would have, those teeth in Heterodontus, they lost their triple layered enameloid and they only have two enameloid layers, which is very different than basically every other true shark that we know of that's like definitively a shark. They all have the so-called triple layered enameloid. So I think Reticulotus would be an interesting one to look at, but I don't think we could rule out convergence if, like, say you were just looking at Reticulotus teeth compared to like other Hybodont teeth and then like Heterodontus and things like that. Yeah,
Yeah,
that
'cause
that would be
if I
interesting.
found reticulotus in the Cretaceous, that would go in the ray jar. But
Yeah, I believe there are Reticulotus. Reticulotus would be in the Triassic, with
yeah,
the
so it's
volcanic.
the Reuveltian fauna. It's the yeah.
Yeah. Yeah, so you would see those there, and yeah, so Hybodonts took over like a Duraphagus role like Reticulotus. You would have a higher cusp taxa as well that would look, I guess, more sharky in tooth design. But yeah, so Hybodonts really took over in the shark niche, but they didn't really reach, large sizes like what we see in the marine reptiles. Yeah, so let's talk about the marine reptiles more of the Triassic. So what exactly was an ichthyosaur?
The ichthyosaurs are, fish lizards that are really the first marine reptiles on the scene. They're as I mentioned, I'll take the ocean 249, 250 million years ago. Or that's when we're starting to get the earliest. That's when we started to get the earliest fully pelagic
Hmm.
fossil. They're they've been proposed to be lots of different things. They've been proposed to be apsids, um, although that portrait is probably, if it's real at all, is probably doesn't have very many members to it.
Hmm.
But so they generally resolve as kind of basal diapsids. We don't really have a good idea of what that kind of ancestral form would look like. There are there are ichthyosaur forms and morphs that are known from China. We've got the Hupasuchians, and the what's that other one? Cardarhynchus. It's adorable. It's like a little ichthyosaur seal. If you guys want a picture, put a picture of that on the screen. I love it. I work for Dr. Martin Sander out in the Augusta Mountains. He suspects that there will be a large change up in kind of these phylogenetic relationships, and is not super confident that any of them are like particularly accurate at this point. So the actual status of Pupasupians and Cardarhynchus is not super known, but they might be a good indicator of what the early ichthyosaurs look like. And they end up in the Jurassic, of course, being they ichthyosaur diversity. They have a heyday in the Triassic. They occupy the most niches, the most size ranges, mixosaurs and being little guys, and to the great shastosaurs, potentially maybe even blue whale range animals in the late Triassic. Then their diversity gets bottlenecked super hard in the Triassic extinction event, and only the Parvipelvians make it through. Parvipelvians are all have that fully cuneiform shape where you only use the tail for propulsion instead of that, the entire anguiform of all the earlier ichthyosaurs. So, but even into the Jurassic, they're contributing. They've got a lot of they're not nearly as diverse as they were in the Triassic, but they've got a lot of members. They can be a very significant component of the Jurassic marine fauna, and potentially even some of the giant predators, like there were dinosaurs that we know they were at least orca-sized. That's at least. There are fragments of bigger things out there. And considering every pliosaur we have keeps getting downsized, I think they're putting a pretty serious contender for the award of the Jurassic oceans.
Mm-hmm.
And ichthyosaurs have been stereotyped by kind of popular culture as the nice dolphin ones or whale ones, based on just purely by the pure vibes of whales and dolphins that they have, when really they're just as potentially formidable and spectacular as any other group of Mesozoic marine reptiles.
Mm-hmm. Yeah. Let's talk about some of the largest ichthyosaurs that we know of, and some of the ones that would have filled a macro-predatory niche that
Okay.
would kind of go against what, that pop culture narrative is.
Right. So I'm of course pretty intimately familiar with the middle Triassic. So first off, something that I'd like to say, if you want to put the Triassic ICZN scale on here, um, something important to kind of clear up about the Triassic is that its stratigraphy is kind of chronostratigraphy is whack. Uh, the early and the middle Triassic are the early and the middle Triassic take place really within the first third of the Triassic. I mean, I don't think this is kind of showing how brief those two time periods, those two, I guess ages, no, not ages. What's the word that will help me out?
Epochs
Epoch,
or
sorry.
epics, however you want to say it.
The epic.
Yeah, I was gonna say this is a good thing to point out is that when we say late Triassic, the late Triassic encompasses
Yeah,
37 million years, and the Triassic itself is only about 50.
yeah.
So
So
definitely in your mind, don't think that those are equally sized chunks of time. The late Triassic is most of the Triassic.
exactly. So when I say Anissian, I really mean the first third of the Triassic. So really the lower parts of the Triassic. Um, so I'm very familiar with stuff from the Anissian and a little bit of the Olenekian and the Livonian. The Anissian is where we're getting like the really big assemblages in Nevada and in most of the Chinese ones are also Anissian. The ones in Spitsbergen are kind of range from Olenekian to Anissian as well. Although a lot of stuff in there is remains to be published. Although I know a lot of people don't know. It's a lot of cool stuff coming there. So I'm very familiar with these guys with the Anissian. And we're getting the really big ones in the Carnian and the Norian. Shastosaurus sicyniensis is Carnian, or excuse me, Norian. Shonisaurus popularis is Carnian. They're attaining large sizes and pretty comparable to uh, whales. And they're a lot of the ones that are better represented don't either have small teeth like Shonisaurus. Shonisaurus in Neil Kelly's paper, he definitively describes Shonisaurus teeth. They're not very big, but they are deeply rooted and have carinae. So they're like, maybe thumb sized, maybe a little smaller, but a whole jaw full. They just fall out really quickly as soon as the animal dies, apparently. But they are known. Shastosaurus sicaniensis appears to be edentulous, no teeth. Although the fact that Shonisaurus, we have like 50 specimens and no teeth were confident, and they were found in the 50s, no teeth were confidently known until pretty recently, a couple of years ago. It draws some attention to whether or not Shastosaurus sicaniensis had teeth. Shastosaurus sicaniensis is the largest ichthyosaur we currently have like a pretty good skeleton of. It's found in the Pardnet Formation of British Columbia, dates to the Norian, and it looks like to be a 70-foot animal, thereabouts.
Hmm.
So maybe it had teeth, maybe it didn't. But a lot of these that we might be seeing, there are some Chinese specimens like a Guanling sort of it's edentulous. It looks pretty similar to like Shastosaurus pacificus. But we have some Shastosaurs with teeth, some with no teeth, and maybe with teeth. So there's a kind of a tenuous relation that remains to be resolved in whether or not these guys had teeth. And we might be seeing like kind of like a modern ecosystem. Some of the big marine tetrapods, drawing a whale cetacean comparison, had teeth and some of them don't. And it remains to be seen. The really big ones like ichthyotitan, and ichthyotitan is only a cirricular. So while I definitely think it's a real taxon, what it is, it's very hard to say anything about its ecology at this point. I'm A lot of people are calling it a predator, including Dean Lomax, or probably a predator. Or like a macro predator. I'm I'm suspicious of 80-foot macro predator. I think bulk feeding is really the only way to possibly get that. Well, I don't think it really is. We don't know so much, but I have not ruled out that it was some kind of bulk feeding.
Hmm.
There are there was a suction feeding hypothesis proposed for large ichthyosaurs back in 2010. There were no apparently that is suction feeding is a behavior that requires a pretty serious physiological adaptations to do that ichthyosaurs look like they didn't have. So it looks like the bulk feeding or not bulk feeding, suction feeding is currently not favored, but some type of bulk feeding in some of these big guys, I think, are likely. That said, there are very, very large ichthyosaur teeth out there in the late Triassic. There was one from the Alps recovered by Dr. Sander pretty recently that's been dubbed in online communities as the Swiss tyrant, and it's a very large tooth. I think it's with the root. It's something like that. And the crown's broken off, but we got the full root. We got the base of the crown. It's kind of that. It's enormous. And ichthyosaurs, even the big macropredators didn't have large teeth. So it didn't have particularly large teeth for its body size. So that could come from a very, very large, something like Himalayasaurus, which is also kind of scrappy, but is a shastosaur with large teeth coming from China. And potentially like in the sperm whale size range or larger.
Hmm.
So that's it for like kind of the kind of trying to with the really big guys. But in Nevada, we have a much better fossil record, and we have an animal called Thalattoarchon saurophagus, which we have teeth for. I might share my screen. So currently, we have three Thalattoarchon specimens known to us.
I actually had a question, Cole.
Yep, go ahead.
So what is the issue with ichthyosaurs suction feeding? Because I don't, to my mind, as someone who doesn't work on them, their skulls aren't so different from something like a beaked whale. Like what? Why can't they do that?
I'm not a, I'm definitely more of like a kind of a field guy. The specific physiological details are something I'm starting to get into now that I'm kind of doing this more and more, but I still am not a great anatomist. So, but there was a paper in 2012 that examined the Shastosaurus brain kind of structure that whales have that they definitely use for suction feeding and found no such thing. Um, I can't say much more than that. I can send you the paper like for further reading,
Yeah,
but
sure. Interesting.
do it afterwards. So it's kind of we're looking for more information if we want to kind of keep that debate going. The Thalattoarchon is a large really the first kind of macro predator. It had large laterally compressed teeth. We have three specimens of it. One is the rear part of the skull, kind of the endocranium, and uh, then a second specimen undescribed but on display at the Reno ichthyosaur exhibition going on right now. Eva is the snout. We don't have a full snout prepped yet, but we got a big chunk of it. You can check that out. I'll send that picture as well. And we have a third specimen that I extracted myself called Ramona, and Ramona is a smaller than the other two, Eva and Jim, which is the name of the holotype specimen. Looked about the same size. Ramona is a smaller, and but it looks like we have a lot more. It's disarticulated. It looks like we have a lot more in her skull. And I say her because she was preggers when she died. She was found by a guy named Raymond. We changed it to Ramona once we found those little fetal ribs inside. So Ramona was our teen mom ichthyosaur. She's my favorite. I like her a lot. But Philato Archon was when it was described in 2013. The authors, Dr. Sandra and his lead authors, the Predation, uh, who are students of his, and they're all on the same team that come out here to that. When it was described, they gave it a very conservative size estimate. They were like, okay, this is a small, this is like a 30-foot animal with a with a disproportionately giant head. They did that because at the time there was no they weren't confident that really that any kind of large animals were there in the ecosystem. So they gave it an intentionally very conservative size estimate, basically just kind of a Symbospondylus with a giant head. With Thalattoarchon specific phylogenetic resolution is kind of floating, but looks very very anguiform, very long and elongated, and maybe more on that later once Ramona is properly described. But so they said it's probably about 30 feet. Then when Jim 2, the giant Symbospondylus youngorum, was discovered and described in 2021, then kind of that removed that cap and credulity of claiming an ichthyosaur of that size. And Jim 2's skull, which I'm sure you can find a picture of online, if you look at ichthyosaurs in like one of the first Google results, is like 6'5", 6'6", and it's the elements that we have. It's the complete skull. It's a little bit flattened, but it's a beautiful skull. Actually, it's right here. You can see that. Bad lighting, but it's on a very popular beer in Nevada called Ichthyosaur IPA. Which it's in Youngorum is the species name is after the brewmaster of the local brewing company who has given us a lot of support for our expeditions out there. Tom Young, hence the Youngorum, and his wife. Lovely people. So, and the elements that we have from Gym 1, the fully prepped out Thalattoarchon, the holotype of the Field Museum, are the exact same size as Mr. 55 to 60 foot long, so Symbospondylus youngorum. So maybe it was a little big headed. So there was a tail preserved along with ribs but there was a big chunk of his middle section missing, and they kind of gave a very conservative estimate. But I think it's likely that we're looking at a 40-foot animal.
Wow. And these big ichthyosaurs, they would basically be feeding on other decent sized ichthyosaurs, right? There wasn't really anything else that was reaching those sizes.
No, there's not. I mean, and they're laterally compressed teeth. They're like the size of my hand, like kind of from here on up. They're enormous, laterally compressed. We're trying to get the teeth kind of rot pretty quickly in the specific preservational conditions we've got. So they rot pretty quickly. So, but hopefully Ramon has got at least a couple that we can prep out and maybe even find some serrations. But um, Zyphodont teeth in marine reptiles is largely unknown. I think there's like one kind of mosasaur that's got it. Plesiosaurs just don't have it. Um, and that kind of speaks to a very strong preference for macro, raptorial behavior, grabbing and seizing large other animals. We have that just for 4 to 6 million years after
Mhm.
the end Permian extinction event.
Yeah.
Paleozoic is uh, super cool, um, and really kind of the first macro, like the first big thing in the ocean that we other big things. Uh, Jim too, the Symbospondylus youngorum, when they collected them, they were like, dude, this is the complete skeletal out of Archon. We got it. And then when they were prepping it out, as they were getting down, they noticed the teeth were much smaller. So the teeth are very Symbospondylus type, small and pointy, pure skilled, I think, right? Pure skilled ichthyosaur. So probably a lot more of a generalist premise. We have a giant, a giant hypercarnivore in the ecosystem, and we have a giant generalist as well. I guess they're all hypercarnivore. A giant kind of macro predator, and one that's a lot more generalist. So both are getting 40 to 50 feet. In Jim 2's case, definitely at least 55.
Hmm.
Right after I left the team, they left the team, had to go back to work. The team went up to British Columbia to do some work up there, and they have sent me pictures that I'm not allowed to share. So much more to come. And even in the fossil hill, every time we go out there, we're like, yeah, we're looking. So
Yeah.
we're up to like 11 species of ichthyosaurs currently, plus a little pistosaur, like kind
Hmm.
of proto-plesiosaur, Augustosaurus. That's actually one of the best preserved of its kind. It's the most frequently cited pistosaur. Um,
Hmm. And I think that Ichthyotitan, which made headlines when it came out, I think that really helped put some spotlight back on ichthyosaurs
yeah,
because we knew of these large Shasasaurid type ones, but I feel like they didn't receive the same type of press or mainstream attention. But when Ichthyotitan came out, like you saw headlines on that on
yep,
social media, and
yep.
I think that's really shining light on
Yes.
ichthyosaurs again.
I proclaimed today a National Giant Ichthyosaur Day. So, but yeah, at Fossil Hill, there's no end in sight. Every time to go out, something is coming up. We've got currently on display in Reno. We have two undescribed species, including a very large Symbospondylus that's not Trinus or Yomorum, a specimen called Mani. I'll send you that to throw up on the screen now. It's
Mm.
probably the most beautiful skull we've recovered from the formation. It's it's pretty spectacular and kind of pretty creepy too. It's a very fearsome looking animal. And we
Mm.
also have a giant Basanosaur type thing that was collected by John Campbell Merriam from the actual Fossil Hill locality, not in the Augusta Mountains where I work, but the actual Fossil Hill locality in 1904. And Merriam was unique in his days that he was a lumper and not a splitter, which is very unique for kind of early paleontology people. And he called it Symbospondylus petrinus, but he ended up kind of masking a lot of diversity that was coming out of Fossil Hill. And
Mm.
it's a giant Basanosaur type. We're not confident it's yet, but very slender snout. Got a 3 foot 8 inch skull. Ichthyosaurs are just getting everything we pull out. So it's new, it's fresh, and there's no end in sight in Fossil Hill, Nevada. And now that we've got a lot more attention on ichthyosaurs from Ichthyotitan, I think we're only getting started. The tide is rising for ichthyosaurs. and they're our uh, cobblestone-shaped livers will bear us to salvation.
Yeah. And speaking of, so we talked a lot about ichthyosaurs, but those aren't even the weirdest things from the Triassic.
But
So,
I know much about these guys, so I'll let
huh?
somebody kind of take point if somebody's got knows more about it.
Sounds good. So what weird marine reptiles have you guys thought of when coming up with I guess your Triassic research for this podcast?
Well, if I could jump in first to do a little bit of orientation, I think this is right around the time that we should kind of consider when we're thinking about how to reconstruct like the ecology of the situation and how it is that we have such huge animals. To think about the paleogeography. So we're still in the Triassic because the Triassic paleogeography is very different in these different periods. So in the Triassic, all of you guys know this is obviously for the benefit of the listener. All of the continents are smushed together into one basically C-shaped megacontinent called Pangaea. The opening of the sea is facing east. And so when you've got one giant continent, you basically have two bodies of water. There's everything that's inside of the sea is the Tethys, and everything that's outside of it is Panthalassa. So when we're talking about these particular discoveries, ichthyosaurs in places like Nevada, up in British Columbia, they're also in Mexico as well. This is stuff that's it's obviously near shore environment, but it's on the outside in Panthalassa and not the Tethys in the interior. If you're familiar with anything in the Triassic, you've probably heard of the Chinle assemblage, the Chinle Formation. So there's exposures of that deposit in Arizona, Utah, Colorado, and New Mexico. So the terrestrial environments that, as someone from the Southwest, that we think about frequently when we think about the Triassic, the phytosaurs, the adasaurs, the earliest dinosaurs or the earliest really proliferating dinosaurs like Coelophysis, um, are Placerius and animals like that. They're living close to the shore. We're just a couple states away in Nevada. We have these environments where gigantic marine animals are lurking. So the earliest dinosaurs are living close to the shore where these massive animals are occurring.
Yep.
Um, so
And
with that said, so we can differentiate between animals living in the interior and on the exterior. That was the stage I wanted to set.
very good point. A point I forgot to mention because I've got a bit to say about this as well. Most of the marine diversity, especially the littler guys, are in the tethys. There, it's all all the Ceratophrygien, the Tanystrophiids, Placodonts, I think Ceratophrygien, but the Thalattosaurs, they're the overwhelming majority of their diversity is coming out of Chinese and European localities in the tethys, um, which are it looks like a much shallower, calmer type of system. And this is kind of getting into some what's currently debated by Dr. Sander and his Chinese colleagues, who's got kind of what the world's oceans look like. And really, the fossil hill member is our first look, but really our only great look into what a true pelagic deep water community looks like. And the faunal assemblage is completely different. There's none of this kind of in all these other localities, especially in the middle, the earlier parts of the Triassic. It's smaller guys. You find the myxosaurs in huge death assemblages. Hundreds of myxosaurs on these hundreds of myxosaurs alongside the nothosaurs and the other ceratophrygines. And they're mostly small. You might get a 20-foot kind of symbispondylid type thing hanging around in there, but they're all small. Then you move over to the Pangaean west coast, and they're giants. It's everything
Mm.
we find is like we do find a good amount of a not small amount of myxosaurs, but the majority of what we're finding are 20+ foot symbispondylid ankylosaurs, and of course the Ladoarchon. And these other little guys are just completely absent. They're just not there. We haven't even seen a hint of them. and except for that pistosaur, Augustosaurus, who's a very notable and important exception. But what Dr. Sandra Kerman thinks, you're not going to find this kind of like stated in any publication anywhere, is that the Tethys is this hotbed of evolutionary origination and speciation, but only the truly like well-adapted pelagic forms are able to make it over the poles because you can't go through Pangea, you have to go around it, and that also is kind of filtering out anything that's not warm-blooded. So all these giant ichthyosaurs we're getting are the only ones that are able to make it over the poles and form these deep sea panthalastic communities.
Right. Yeah, you have to think of just kind of this general idea of the size of the goldfish being determined by the size of the bowl. Not an exact biological rule of thumb here, but with a much larger ocean basin to be dealing with on the West Coast represent, right? Nutrient cycling is going to be very different when you have a global, Panthalassa is pole to pole. So that kind of the nutrient cycling in a situation like that. And large body sizes are certainly very useful if you are transporting very long distances. Certainly helps.
Yep. And but exactly. And what that also means is that we have a kind of a limited glimpse into what the actual world's oceans look like. So we know a good idea of what like their version of the Mediterranean was like. It does get kind of deep, but it's mostly shallow and coastal environs. But we don't have most of the localities up until recently are these shallower Tethys localities. And I think that the world's oceans might look quite the world's like the Great Panthalastic Ocean, the world spanning coast to coast Pangean or Triassic and Permian ocean is kind of the fauna there is going to look quite different. Probably a lot more similar to what we're seeing in Nevada. A notable exception to this is a Spitsbergen. Spitsbergen looks like it was in some kind of smaller enclosed, like inland sea type environment going on, but a lot more open to the open ocean. And what its specific kind of paleo environmental status is, it's less clear, but a very interesting research going on.
Now, Chase, I know that we did a little bit of research on the other Triassic marine reptiles. What were some of the weird ones that you found?
Yeah, the Placodonts were really, really interesting. Very goofy looking, very turtle-like. Of course, they aren't turtles. Um, However, from what I've been reading, it seems like they do evolve shells the further into the Triassic they get. And I guess that kind of brings me to the question I have for Cole. I guess predation, like ichthyosaur predation, like how much evidence do we have of it, and do we have it on like bigger animals, typically smaller animals? I assume ichthyosaurs would have probably been eating a fair amount of invertebrates, but I'm just curious, particularly predation, maybe.
So most of our ichthyosaur gut contents come from the Jurassic. Lots and lots and lots, especially the ophthalmosaurs. Lots and lots of squid hooklets in their stomachs. Fish are known but less common. For Triassic, so before I leave the Jurassic, there was an incredible specimen prepped by my colleague Jean-Philippe Bluit that is not described but currently on display at the Reno Ichthyosaur exhibition of a Jurassic, so probably Ichthyosaurus communis, that has a healed bite mark from a plesiosaur and not a pliosaur, plesiosaur. So we have evidence of that kind of very, very Victorian paleo art of trope of an ichthyosaur fighting a plesiosaur, ichthyosaurs fighting a plesiosaur. So just wanted to mention that and give a shout out to Jean-Philippe because he's one of the best prep guys in the world. So there's also in my very recently, like a reading I did yesterday, there remains other ichthyosaurs and Jurassic ichthyosaurs. I don't know what specimen who was eating who, but I know that exists. Triassic, we have up in Alaska, Pat Druckenmiller described really kind of the only good Triassic ichthyosaur known from Nevada. It doesn't have it's not described as a new species or anything like that, but it preserved gut contents. I don't think it's got a skull, but it preserved or much of a skull. It preserved gut contents of uh, mostly fish. Um, yeah, I think it's just osteichthyes, kind of osteichthyes remains. And then the other big one that I wanted to mention was so marine reptiles are frequently broken into guilds, the cut guild, the pierce guild, and the smash guild. Am I getting that right? Kind of based on tooth shape. Uh, really, cut gill animals are rare. Thalattoarchons definitely one, but they're ones with distinct carinae and teeth in marine reptiles are less common generally. That goes for kind of mosasaurs and plesiosaurs as well. But we have a it's been thought that this is kind of a pretty good indicator of what the ecology was like. But over in China, they have a shastosaur called a ichthyosaurs that was a pure-skilled ichthyosaur, and it had ripped the head off of a thalattosaur. Its carcass was sitting a few feet away, and it had recently just devoured the head of the animal. And so there goes, it was a pure-skilled, and it was doing something extremely macro-raptorial. So there goes that whole ecological breakdown. But maybe it's more of a generalist, and generalists can take big stuff too. But we have some gut contents of a shastosaurid, a small shastosaurid, but a shastosaurid, toothed shastosaurid eating a thalattosaur.
It's pretty cool. I just want to talk about a few of the other oddball, I guess we can call them like dead end Triassic lineages. So like Tanystropheus, if you remember in Chased by Dinosaurs, in that Triassic one, that animal with a really long neck and the head and the small head, those things are so wild looking. Like I believe they're an archosauromorph,
Yep.
but I mean, they have a neck that, isn't, I guess, super dissimilar to like a plesiosaur, and they had like
Can I say something about that?
yeah.
They're doing a very like convergently mammalian thing with their neck vertebra, unlike plesiosaurs, where instead of adding more vertebra, they're actually extending a few, more like a
Oh
giraffe,
wow.
which is really cool. Yeah, we found a couple of their vertebrae and some Chinley stuff I worked on undergrad, and they were little guys, but they're pretty cool.
On Shinley stuff,
Yeah, yeah,
Interesting.
yeah.
Shinley
So I just had to add that because I think that's like so cool.
are
Yeah.
more likely than you think, apparently, because that's wild. That's really cool. Or would they have been like freshwater Tanystrophians?
Right. So that's the maybe.
Have they been described?
Yeah, yeah. I think a lot of sites in eastern New Mexico have them, and it sounds like the other Ben knows this Chinley pretty well too. So correct me if I'm wrong, but yeah, you find them in freshwater assemblages, and they're little. So it's not Tanystropheus is a longicaudalis or whatever the type, the big one from Switzerland is. But yeah, you get them in freshwater, just kind of nuts.
Hmm. Another weird animal from the Triassic was Cole, you said it briefly, Hupasuchus,
Yeah,
which has it's hypothesized that it was a filter feeder.
something like that. Yeah,
Hmm.
I don't. Sorry, I should have done more prep work on my nodding stuff, but
Yeah, you're good, but you basically had in the Triassic a marine reptile that evolved filter feeding I guess niche, and it kind of would have fed like a baleen whale from what I've read. Albeit I'm not a reptile guy. I'm a chondrichthyan guy, but I found that so interesting seeing those. And then in the Triassic, you also had your early plesiosaurs, like you had Redicosaurus, So that I believe is an early basal pliosaur, which is cool. So you had these animals that became, I guess, like really prominent in the Jurassic. Like pliosaurs were, one of the top dogs, albeit they were shrunk a good bit since the Walking with Dinosaurs days. But still cool nonetheless in the Jurassic, but they weren't nearly as fierce looking in the Triassic. They were like just getting their roots over there. And then another weird one was Atopodentatus, that herbivorous marine reptile from the Triassic. Those things look wild too. Have you seen those?
I have. I just kind of want a picture to just kind of
Very
just
wide mouth.
just gaze at.
Yeah.
Yeah, it's either a wide mouth or like a split mouth. Yeah, a lot of weird Tethys stuff. And I think kind of characterizing them as kind of dead end lineages is a bit unfair to them because the Triassic is almost as long as the Cenozoic is, right? And so, like, if, for example, let's have the whales go extinct um, right now, and they don't persist longer. Would you call? I wouldn't call them a dead end lineage just because they only had a 40 to 50 million year run of it.
Hmm.
But yeah, a Topodentatus also mid Triassic, it's sort of really the earlier part of the Triassic.
Yeah. And we also had Nothosaurs. Those didn't make it past the Triassic, right? Yeah. So those would be another, I guess, like quote unquote dead end.
Yeah, but they're I mean they're Sauropterygians and like kind of on the plesiosaur line. So
Yeah.
uh, the dead end if you kind of they plesiosaurs probably come out of something.
Hmm.
You
Yeah.
know,
Those
Joel,
are my favorites.
the
Nothosaurs.
Nothosaur?
cool. Yeah, they got big too.
Yeah,
Like I'm trying to think
they
about
do.
yeah, like 20 feet. That'd be kind of scary.
Yeah, they're kind of like maybe sea lion like, kind of like hanging out on coastlines. I think they're known from mostly shallow marine
Yeah.
deposits, and they look like they can get on land. And they
Mhm.
have these like Venus flytrap heads. They're really cool. I really like Nothosaurs.
Uh,
The other one is the thalattosaurs, which are really weird. Which are these kind of like um, I think they're diapsids and they're probably neodiapsids, and I think that's all we really know about them. But they show up in these like accreted terrain marine layers that on the Pacific. Correct me if I'm wrong.
yep.
Cole.
Not none published from Fossil Hill, but we're might change. There's the fossil so the Fossil Hill member is kind of split up over two real like areas that actually produce fossils. There's Fossil Hill and then like 50 miles to the east, the Fossil Hill and the Humboldt Mountains, and then 50 miles to the east. You have the Augusta Mountains where I work. Same, very correlated via faunal assemblage, both invert and vertebrate. Um, but John Campbell Marion, so historically, the actual Fossil Hill, it was really important to getting kind of Symbispondylis described. A lot of really good specimens of Symbispondylis. The one on display at the Reno Art Museum right now. I'll send you a picture to put up here because I actually assembled it for the exhibition. Um, it's super important historically, very early on in paleontology, but we kind of thought it was tapped out in terms of like what it could actually tell us. But funnily enough for Nevada, it's private land. So it's privately owned by a guy who had a meeting with us this year. He wanted to show us what he had just kind of by himself in his backhoe. He'd been digging there. Shout out to Pat in Washington. And let's just say it's not that. He's finding stuff like melanosaurs there. And even some of the lower Triassic stuff is also producing. And I mean actual lower Triassic materials coming out there. So, um, well, maybe more comes soon.
I have another really weird one. Have you guys heard of Eretmorpus. I think it's the weirdest looking Triassic animal.
Wow. Yeah. I've seen pictures of them. That's,
Those things are crazy. Like if we traveled to the Triassic, not knowing anything about paleontology or whatever, we would think we're in an alien world. Like it's there's so much experimentation that happened there. I think it would be one of the most interesting periods to go back to.
I know this is not a marine animal, but I just have to bring up Van Clevia too, because that's another one of my favorite like Venus flytrap headed things.
I don't think I've heard that one.
It's
Oh,
so
you
it's from
have
Ghost
to.
Ranch. It's so cool, and it's this like it's maybe a basal archosaur or something, but it's this kind of convergently otter-like reptile that's hanging out with phytosaurs and metoposaurs in the rivers, and it's got these like I think they're osteoderms. It's got a covering of what almost look like ganoid garfish scales,
Yeah, pretty
and
heavily armored.
yeah, and there's a dennery at the Mesolands Museum, which is like maybe a 15-foot version of this much smaller, better fossil from Ghost Ranch, which is kind of nuts that they were getting pretty big. So, but we don't know if that was a marine animal or not. It's like certainly in these fluvial facies, but it's a really cool looking critter.
it's a
Yeah.
very yeah. It gives me like heart of gold. So real quick before we move on from the Triassic, I want to give a shout out to the Omphalosaurs, which have three species. I think one European and two. One's lower, actually lower, like Olenek, Enaricus. The other one that we get at Fossil Hill is how am I forgetting? It's another species. Um, and we don't. None of the paleo art currently for Omphalosaurs accurately is accurate. That we don't have know what a skull looks like. We have skulls that are being prepped right now, but we don't. None of them are figured yet. We don't know yet. So more to come on that soon. That's a pattern that I've been seeing for a lot of this. But Omphalosaurs look like they're pretty common. They've got particularly broad ribs. We can identify. They're one of the things we can like. We don't have to get them prepped to actually kind of figure out that that's what it is. They got pretty broad ribs and entirely durophagous dentition. So they had a whole skull full of flat munching, flat crushing teeth. They're I'm just going to say they're definitely anatomically specialists. Given that we find that that's made out of it. So and are probably a pretty important part of that middle tier of the ecosystem for the Paleozoic ocean. So just wanted to shout them out because I don't want to forget the humble Alpinosaur. So